Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll deal with Mathematics class 12th further, and the chapter that we are currently studying, currently solving is integrals. Now is the turn of exercise 7.2. Now this particular exercise is based on some methods of integration. One of the very important methods which we want to learn right now is method of substitution, and this particular exercise is based on that very method. Right. So let's see, along with the questions we'll see the concepts involved, and the important thing to identify in such kinds of questions is what to substitute and when to substitute. That's the important thing. So along with the questions we'll be dealing with those ideas as well. Let's begin with the first question. The question says integrate the functions in exercises. Okay, there are so many questions, 37 questions here. The first question has 2x upon 1 plus x square. So what are we supposed to do? We are supposed to integrate this. Okay, I equals integral of let I equals integral of 2x over 1 plus x square dx. Now the first and foremost thing that you need to realize just after reading this question is, okay, do I know how to find the integral of this? Now, had this 2x been below, you could have divided easily, right? Had there been a power which is higher than this 1 plus x square in the numerator, in power higher than x power 2 in the numerator, you could have divided. But then in this particular question, this is a lower power, this is a higher power. Okay. You may also think in one of the results of 1 upon 1 plus x square, right? Integral of 1 upon 1 plus x square is tan inverse x plus c. But you observe there is a 2x at the top, which is creating a lot of problems. But do you also realize that the derivative of this 1 plus x square is what? That is 2x, right? So the derivative of 1 plus x square is sitting with the dx, and that's the important key. That's the important key. That's the idea of substitution, that we can take 1 plus x square and convert it into a new type of variable, right? Let x plus 1 plus x square is equal to new variable t. If 1 plus x square is equal to t, then you can write, okay, the derivative of this 2x dx will be equal to this dt. What have we written over here? What have we done? We have substituted 1 plus x square as t, and then we have taken the derivatives both sides. Okay, with respect to what have you taken the derivatives? You could have taken derivatives with respect to anything. Let's say with respect to z. So 1 plus x square dx upon dz is equal to dt upon dz. The dz skew. And this is how we actually write it at the end of the day. Right? You could have written, okay, in terms of t, let's say if you want to take the derivative in terms of t, 1 plus x square, the derivative will be 2x dx upon dt. This will be 1, and this dt will come over here. That's not important. The important thing is that the derivative of this is this, the derivative of this is this, right? And with the help of this, I can convert this integral I in terms of new variable t. And how will I write it? This is 2x times dx, which is equal to dt in the numerator. 1 plus x square, at every location convert that x in terms of t. So 2x dx is gone, that becomes a dt. 1 plus x square is equal to t, this is what I get, yes. And integral of 1 upon t with respect to t is pretty simple, right? We know that this is equal to log of modulus t plus constant of integration. Is that the final answer? This is very, very close to the final answer, because you cannot leave the answer in terms of t. We have to go back to that x. And t is equal to 1 plus x square. So this becomes log of 1 plus x square plus c. Log of mod t, then log of mod 1 plus x square. Okay, if you apply a bit more logic, you can say that 1 plus x square is always positive. So this modulus is not useful. We can use a simple bracket as well. Yes, you could do that, or you could leave the answer at this stage only. This is the final answer for this question, log of mod 1 plus x square plus c. Now mod of 1 plus x square is same as 1 plus x square. That's something which I have mentioned, right? This is the first question and the complete solution for that. Let's move on to the next one after this. The second question says, okay, we have log x and its square, right? And we have x in the denominator. So always think, anything complicated that you see, can you use substitution for that and simplify it somehow? That's the key, right? So we see, okay, log x in itself is pretty complicated. There's a square of log x, that's very, very complicated. But then there's an x also in the denominator. And that tells me, okay, the derivative of log x is, 1 upon x, right? And that 1 upon x is present over there. Yes. So I write I as integral of log x square upon x dx. We want to integrate this whole thing, right? And for integrating this, the important thing that we observe is the derivative of log x. The derivative of log x, what is that? We'll take log x equal to t, and the derivative of log x is 1 upon x. Okay, dx. Okay, this is equal to dt. Oh, the derivative of log x is present with this dx. Yes, it is already present over there. Right. So with the help of this, therefore, I will convert to what? I will be integral of, convert at all places, replace x in terms of t. So log x is simply t, this becomes t squared. Dx upon x, I observe dx upon x is simply dt. This is what I get. And integral of t square, oh, that's pretty simple. T square, the integral will be t power 3 upon 3 plus a constant of integration. And at the end, we need to replace that t in terms of x again. So this is 1 by 3 is okay. T power 3, t is log x, right? So this is actually log x power 3 plus constant of integration, and yes, that is the required answer for this question, as you can see, right? In the third question, we have 1 upon, okay, x is there plus x log x is there. Oh, once again, that log x is creating problem. So we can substitute log x in terms of something. That is one idea we already have. But if there is a 1 by x there somewhere, do you see a 1 by x there? Yes, there is a 1 by x. It's hidden directly. It's not in plain sight. But then, do you observe that x can come out common, and what will remain is this. Now I see that 1 by x. Yes. It was slightly hidden. You could say, so what is hidden in this? There's something hidden in this. But this is how it is, right? That log x can be substituted as t, or I can substitute that 1 plus log x as 1. That 1 will not create a problem, right? Yes. So let 1 plus log x is equal to t. Differentiating this 1 will not create a problem. Differentiating this 1 will give me a 0. So 0 plus derivative of log x is 1 upon x times dx is equal to dt. This tells me that, okay, dx upon x is equal to dt. Therefore, the integral I becomes equal to what? Dx upon x. Dx upon x is dt. Integral dt is what I have. And 1 upon this 1 plus log x. 1 upon 1 plus log x is t. Okay, this is what you have. 1 upon t, dt is what I get. And what's the integral of 1 upon t? That is log of mod t, and you add a constant of integration. Replace that t in terms of x once again, and we get the final answer. Log modulus t is equal to 1 plus log x modulus plus c. This is what you have, and that's the answer for this question. Pretty complicated looking integral, but with substitution things become very, very simple, right? That's the final answer for this third question. Fourth question says we have sin x, and then we have another sign, but there is a cos x inside that sign. Okay, so how will we handle that? Okay, you see something complicated and you realize that that complicated thing can be simplified with the help of substitution. Yes. So the integral will be sin x times sine of cos x dx. Okay, this cos x is creating a lot of issues for us. Yes, but the derivative of cos x is minus sin x. So already present with the x, right? Yes. So we can substitute. Let cos x is equal to, instead of t we can use another variable, or we can use t only. Let's use t. That tells me minus sin x dx is equal to dt, and therefore integral I will be equal to what? sin x dx. Sin x dx is dt with the minus. So you get minus of dt. Oh, what else? You have a sine of cos x, sine of t waiting around here. This is what you have. Yes. Now, minus will take care of itself. That's not an issue. Minus will be moving out. Integral of sine t. What is that? Minus cos t. So there's a minus outside. Then you have a minus cos t plus a constant of integration. This becomes cos of t plus constant of integration. But you should replace that t again in terms of x. What's that? This is cos x. This is cos of cos x plus c is the required answer for this question, as you can see over here. That's the final answer for this fourth question. Fifth question has, okay, sine of ax plus b, cos of ax plus b. How do we handle this one? How do we handle this one? Let's take a look at this question. So we have sine of something, cos of something. Let us write integral I as sine of ax plus b times cos of ax plus b dx. The first thing that we observe is this ax plus b is looking pretty complicated, is it not? Yes, it's looking pretty complicated. But other than that, this sine and cos product is also complicated, right? So can we apply some concepts of trigonometry to merge these expressions? Merge these expressions? What do you mean by merge? Okay, I want to use this identity that 2 sine theta cos theta is equal to sine 2 theta. Do you recall this? Yes. 2 sine theta cos theta is sine 2 theta. You remember sine 2 theta is 2 sine theta cos theta. Therefore, this 2 here, sine theta cos theta will be half of sine 2 theta. Yes. Using this one over here. This is what I want to use. This integral will convert to what? Sine theta cos theta will be half of integral sine 2 times ax plus b. Dx. This is what you have. Right. And this is a simple sine. This looks like sine 2 theta, right? How do we handle this? So for handling this, there's one relation, right? There's one relation. We can use that relation, but without using that relation. What is that relation? We'll be talking about that. If instead of sine x, we have a sine of linear polynomial in x, then what do? We'll be talking about that. That is something that I've dealt with in exercise 1 as well, along with exercise 1. But I'll deal with that again over here since it is a concept of substitution that's required over here. But in this particular question, how do we solve it directly? So this huge complicated expression is creating problem. Let 2 times ax plus b is equal to new variable t. If you write it as this, then this tells me, okay, 2 times a times dx is what remains. 2 times a dx, 2b the derivative is 0, this is equal to dt. Okay. So therefore I will be equal to what? Therefore I will be equal to integral. There is a half outside. Sine of this whole expression, which is sine of t, dt. Yes, this is what you'll get. Okay, half remains as it is. Integral of sine t is minus cos t dt. Now this becomes minus 1 by 2 cos of that huge expression. Okay, there's just one issue. What's that issue? We missed out on one particular thing. Let's not miss out on things. Okay, sine of t is okay. Dx is not directly dt. Dx is dt upon 2a. Remember that. This is dt upon 2a. Okay, so dt upon, let's get rid of this. And at this stage, what do I have? I'll have a 1 by 2a. Okay, the integral of sine t is minus cos t. 1 upon 2 is already there. 1 upon 2a is already there. And you'll have a constant of integration. Right? Let's not miss out on things. This is what you'll have. And this becomes minus 1 upon 4a cos t plus constant of integration. Right? Missed out on the constant of integration. Minus 1 upon 4a is okay. Cos of t. T is equal to what? That. 2 times ax plus b. This is what it is equal to plus constant of integration. That is the required answer for this particular question. Okay. And what is that important result that I wanted to share with you? The important result is this, that if integral of fx dx is equal to capital Fx plus constant of integration, then integral of f of linear expression ax plus b this dx, if you have a linear polynomial, instead of x, if you have a linear polynomial, this becomes capital F ax plus b upon a plus constant of integration. Similar expression, just that in the right hand side you have to divide by that a. That expression has to be divided by a. This is only true if you have a linear polynomial here. If you have a linear polynomial here. And for deriving all of this, what have we done? We can simply say, for deriving all of this, you can simply use substitution, right? Ax plus b. For solving this, what you can simply do is ax plus b can be replaced by t. Similar manner, in a similar manner that we have done over here. If ax plus b is equal to t, then a times dx will be dt, and f of t dt upon a is what I'll get. Integral of f of t will be capital F of t, and there will be a in the denominator. Yes, t can be replaced by ax plus b, and this is what you get, right? But this is one thing that you need to remember from now onwards. Right? This will be used over and over again in multiple types of questions, and we need to remember this. Right? We'll memorize this, and this is using the idea of substitution that we have derived this. Okay, and this could also be done with the help of simple inspection as well. But using some, let us say, substitution, this becomes very simple. The solution of this particular question is this. You could have also begun in another way, that you could have said, okay, sine of something dx, I know how to integrate that. If this is a linear expression, this will be half is okay. Sine of something will be minus of cos that something divided by the coefficient of x, which is 2a, plus constant of integration. And this, can you observe that this and this are the exact same answers? Minus 1 by 2 into 2a is minus 1 by 4a, and you have cos of that huge expression plus constant of integration. Exact same. So after this, you could have moved in this direction. Instead of going this longer approach, you could have moved directly over here, provided this is a linear expression. This is a linear polynomial in terms of x, right? That's what you have. So with the help of this result, many such questions can be solved easily, right? These long steps of substitution can be skipped, right? Okay. So that's the fifth question for us. Yes, that's a complete solution and one extra result based on that. I'll get aside so that you can take a look at this. That's a complete solution of this fifth question. In the sixth question, we have square root of ax plus b. And now you can directly think, okay, this is similar to square root of x. What is integral of square root of x dx? That is x power 3 by 2 upon 3 by 2 plus c. Okay. So what about integral of root ax plus b dx? This will be equal to what? This will be equal to ax plus b power 3 by 2 upon 3 by 2 plus c. But don't miss out on one important thing. What is that? Since this is a linear expression, linear polynomial, you have to divide by this coefficient of a. This expression has to be divided by coefficient of a, x, that is a. This is 2 by 3a times ax plus b power 3 by 2 plus c, and yes, that is the required answer for this question over here. Integral of ax plus b. Oh, but I want to solve using basic ideas of substitution. If you want to solve using those things, then also you can solve this. I is integral of root ax plus b dx. This particular question I'll solve using the other approach also. Let ax plus b is equal to t. What does that give me? A times dx is equal to dt. This tells me, okay, dx is equal to dt upon a. Therefore, the integral I is integral of root t dt upon a. Do you observe that? Yes, dx becomes dt upon a. Now, integral of root t is t power 3 by 2 upon 3 by 2 times 1 upon a plus constant of integration. Yes, and this is exactly same as this. This becomes 2 by 3. That a comes over here, 2 by 3a, and t is ax plus b power 3 by 2 plus constant of integration. The exact same thing, but you realize that this linear polynomial substitution in terms of t is kind of some extra steps, right? Just some extra steps. If you remember this whole thing and this division by a, we can always solve this question easily, right? This is 3a, 2 upon 3a, right? Take care of that. And next time onwards, we'll be using this idea and we'll be solving questions using this approach. Okay, let's continue further. The 7th question says we have x times under root of x plus 2. Now, how do we solve this one? Okay, we have x times under root of x plus 2. So, for solving this under root of x plus 2 is creating an issue. Okay, that x plus 2 can be substituted in terms of something, right? I is integral of x times under root of x plus 2 dx. In the previous exercise also what we have, if we had under root of x over here and x plus 2 over here, things would have been simpler, right? That root x could be multiplied inside and we could simplify easily, right? And that's what will be our aim. So let x plus 2 is equal to t. That tells me, okay, derivative of x is dx, 2 is gone, the derivative of t is dt. Therefore, I will be equal to integral of this x is actually t minus 2, under root of x plus 2, under root of t, dx is dt. Replace x in terms of t throughout. This is what you have done. Now, this simplifies to integral of t times root t, which is t power 3 by 2, minus 2 times root t, 2 times t power 1 by 2. This is what I have. And now can you integrate this? Yes. Which gives me I is equal to t power 3 by 2, the integral will be t power 5 by 2 over 5 by 2 minus 2 is already there. The integral of t power 1 by 2 will be t power 3 by 2 upon 3 by 2 plus constant of integration. This becomes 2 by 5 t power 5 by 2. Now what is t? T is x plus 2 power 5 by 2 minus this is 4 by 3 t times t power 3 by 2, which is x plus 2 power 3 by 2 plus constant of integration, and yes, that's the required answer. That's the required answer for this question, as you can see over here. That's the 7th question for us. In the 8th question we have, okay, under root of 1 plus 2x square. That's creating a problem, right? Okay. And there lies the key. The derivative of x square will be in terms of x, right? Constants will take care of themselves. That's not an issue. So we are looking at integral of x under root of 1 plus 2x square with respect to x. Let 1 plus 2x square is equal to t. This is what we'll begin with. If this is equal to t, then you have 4x dx. Derivative 1 is gone. Derivative of 2x square is 4x dx. This will be equal to dt. Or you can say derivative of x dx will be dt upon 4. Because you need x dx, right? Therefore, I will be equal to integral of x dx is dt upon 4. Root of 1 plus t square is root of t. This is what you see, right? This tells me, okay, I is 1 by 4 is okay. Integral of root t dt is what we are interested in. 1 by 4 is okay. Integral of root t will be t power 3 by 2 upon 3 by 2 plus c. What will this simplify into? This 2 goes at the top, 2 by 4 into 3, 2 by 12, which is 1 by 6. T is okay, 1 plus 2x square power 3 by 2 plus constant of integration, and that is the required answer for this question, as you can see. That's 8th question for us. In the 9th question we have, okay, there's a 4x plus 2 outside, and in the under root we have x square plus x plus 1. It looks complicated, right? So you can use this substitution, x square plus x plus 1 equal to t. But for that, the derivative of x square plus x plus 1, what is that? 2x plus 1 should have been outside. Now 2x plus 1, okay, this is 4x plus 2, but we can take out a factor of 2 common. This becomes 2x plus 1 times 2, yes? And that's the standard substitution now. This is 2 times 2x plus 1 under root of x square plus x plus 1 dx. This is what you have. And now we'll use the substitution. X square plus x plus 1 is equal to t, which tells me, okay, 2x plus 1 times dx is equal to dt. Therefore, integral I simplifies to what? I will be equal to integral of 2x plus 1 times dx is dt. Okay. There's a 2 remaining outside. That will remain over here. That can go outside the integral. This is root of x square plus x plus 1, which is root t, sorry. Okay, that's pretty simple, which gives me I is equal to 2 is okay. The integral of root t will be t power 3 by 2 upon 3 by 2 plus constant of integration. This is 4 by 3 times t power 3 by 2. Now t is this, x square plus x plus 1 power 3 by 2 plus the constant of integration, and that's the required answer for this question, as you can see over here. This is 9th question for us. In the 10th question, we have 1 upon x minus root x. Now on first looks, it looks like, oh, what will we do in this one? Everything is there in the denominator. But that root x and x, can you take out a root x common? Yes. What will remain is root x minus 1 in the bracket. Okay. This is a problem and this also is a problem. Yes. But when they come together, do you see that one will lead to the solution of the other? Yes. You can take, okay, root x, the derivative of root x, what is that? That's 1 upon 2 root x, right? Okay, 1 upon 2 root x. So let root x minus 1 be t. This tells me that 1 upon 2 root x dx is equal to dt. This is what you observe, right? So therefore, I, the integral will be equal to dx upon root x, which is 2 dt, upon, this is root x minus 1, which is t. Okay, 2 will take care of itself. 1 upon t, the integral is ln or log mod t plus the constant of integration. That's what you have, right? Log of mod t is root x minus 1 plus the constant of integration. That's the required answer for this question, as you can see over here. This is 10th question for us. That's the complete solution of this. In the 11th question, we have x upon under root of x plus 4, and we are also given that, okay, x is greater than 0. Now, how do we handle this one? So, under root of x plus 4, had that been only under root of x, things would have been simpler, right? So, let's do that. Let's use that idea. I is equal to x upon under root of x plus 4 dx. We are interested in this, right? Let x plus 4 be replaced by t. That tells me, okay, dx is equal to dt, and this tells me that I will be equal to what? In the numerator, you have x becomes t minus 4 upon root of x plus 4, which is root of t, and you have dx, which becomes dt. This can further be simplified into, by separating the terms, t upon t power 1 by 2, which becomes t power 1 by 2, minus 4 times, denominator has t power 1 by 2, that becomes t power minus 1 by 2 over here, integral dt. Now, integral of t power 1 by 2, what is that? T power 3 by 2 upon 3 by 2 minus 4 times, the integral of this will be minus half plus 1, which is 1 by 2 upon this 1 by 2 plus the constant of integration. This will simplify to 2 by 3, t power 3 by 2. Now, what is t? T is x plus 4 power 3 by 2 minus, this is 8 root of t. This is root of t, right? Root of t is actually x plus 4 plus the constant of integration, and that is the required answer for this 11th question, as you can see over here. That's the required answer for this 11th question. For next, the 12th question says, okay, you have x power 3 minus 1 whole power 1 by 3, and then you have x power 5 outside. Okay, that power 1 by 3 over x power 3 minus 1 is creating problem, right? So I will be equal to x power 3 minus 1 power 1 by 3 x power 5 dx. Now, the first and foremost important thing is to identify the term which is creating problem. This term is creating problem. So let x power 3 minus 1 is equal to t. Without worrying about what will it convert into, though I am worried about that as well. What I see is the derivative of x power 3 is x power 2. Okay, this x power 5 has a x power 2 and x power 3 hidden inside it, right? So x power 3 can be substituted from here. X power 2 will go with that dx and it will convert into dt. Yes, that's the important thing, right? So this is 3x square dx becomes equal to dt. Therefore, I is equal to integral of x power 3 minus 1, which is t power 1 by 3, times x power 5, which is x power 3. This can be written as, okay, x power 3 minus 1 power 1 by 3. Let me split that. X power 3 times x square over here only dx. Let me split that. So this is t power 1 by 3. X power 3 is actually t plus 1. And x square dx. X square dx is dt upon 3. dt upon 3. This is what you get, right? So that 1 by 3 will come outside. In the integral, what you'll have is t power 1 by 3 into t is t power 4 by 3 plus t power 3 1 by 3 into 1 is t power 1 by 3. dt is what I have observed over here. This is what I have. Now I can integrate this. Therefore, I will be equal to 1 by 3 is outside. The integral of t power 4 by 3, what will that be? That will be t power 7 by 3 upon 7 by 3 in the bracket plus t power 1 by 3, the integral will be 1 by 3 plus 1, which is 4 by 3 upon 4 by 3 plus the constant of integration. What will this be? This is 3 by 7 into 1 by 3 will be 1 by 7 t power 7 by 3 plus 3 by 4 into 1 by 3 will be 1 by 4 t power 4 by 3 plus c. This is what I observe. And what else? T can be substituted again in terms of x. This is 1 by 7 x power 3 minus 1 power 7 by 3 plus 1 by 4 x power 3 minus 1 power 4 by 3 plus the constant of integration. And yes, that's the required answer for this question, as you can see over here. This is the 12th question for us. In the 13th question, we have x square over 2 plus 3x power 3. Now you observe there's x power 3 over here and its derivative is lying over there. Right. So we can substitute that term in the denominator as t. I equals integral of x square over 2 plus 3x square power 3 dx. Okay, the constants will take care of themselves, right? So 2 plus 3x square can be taken as t. Sorry, this is not 3x square, this is 3x power 3. Right, therefore we'll get the derivative over there. This is 0, this is 9x square dx, which is equal to dt. And once I observe this, therefore this I becomes equal to what? X square dx is dt upon 9, 1 upon 9 dt is what I get. The 1 upon 9 will come outside the integral without affecting the integral, right? And this here is 2 plus 3x power 3, which is t. In the denominator you have t power 3. Okay, 1 by 9 t power minus 3 dt is what I have. 1 by 9 is okay. What's the integral of t power minus 3? This is t power minus 2 upon minus 2. You add a 1 and this is what you get, plus c. Which tells me that I is equal to, okay, you have an 18 in the denominator with a minus, and you have t power 1 by 2, sorry, t power minus 2, which becomes 1 upon t power 2, 1 upon t power 2. What is that? Okay, let's write t power 2 plus constant, that is minus 1 upon 18 t square. T is 2 plus 3x power 3 square plus c is what I get as the answer for this 13th question, as you can see behind me. That's the 13th question for us, yes. In the 14th question, we have x times log x power m in the denominator. X is greater than 0 and m is not equal to 1. Okay, if that is the case, then where does that take us? Now the derivative of log x is simply available over there, right? So I begin with I is equal to integral of 1 upon x log x power m dx. This is what I begin with, right? And what else? If I can substitute log x equals t, that tells me that 1 upon x dx will be equal to dt, and therefore this integral will convert into integral of dx upon x. Dx upon x is dt, that is in the numerator, and here in the denominator you have log x which is t power m. Now t power m, this is t power minus m dt integral, which becomes t power minus m plus 1 upon minus m plus 1 plus constant of integration. Now this minus m plus 1 should not be 0, that's important, right? So m should not be equal to 1, that condition is already given. And why is that x greater than 0? So that log x is defined, right? That's the condition for that. And once I reach this stage, this is 1 minus m in the denominator, this is t power 1 minus m, t is 1 log x, right? So 1 upon 1 minus m times log x power 1 minus m plus constant is what I get, and that is the required answer for this question over here. This is 14th question for us. In the 15th question, we have 9 minus 4x square in the denominator and x in the numerator. Okay, the derivative of x square is present over there, so we'll use that simple substitution. Okay, I equals integral of x upon 9 minus 4x square dx. Let 9 minus 4x square is equal to t. If that is the case, then minus 8x dx is equal to dt. And this further tells me that x dx integral, I will tell me x dx is minus 1 by 8 dt over 9 minus 4x square, which is t. Okay. And this is minus 1 by 8 is okay. Integral of 1 by t dt, what does that convert into? Minus 1 by 8 is okay. This is log modulus of t plus constant. We can substitute t from there. Minus 1 by 8 is okay. Log of modulus 9 minus 4 x square plus constant, and that is the required answer for this question over here. That's the final solution for this question. The 16th question says that we want to integrate e power 2x plus 3. Now this particular thing can be handled very easily if you recall one important thing that I have just told you in the very beginning in one of the initial few questions, that instead of e power x, what do we have? E power 2x plus 3. Now this is a linear polynomial of x, that's one idea, and therefore integral of e power 2x plus 3 dx will be equal to e power 2x plus 3, that's same, since integral of e power x is e power x, right? So this is this, and you need to divide by this 2 plus constant, that is your required answer for this question. Alternatively, if you want to use pure substitution, so what you will do is, for integrating e power 2x plus 3 dx, I equals this. This is alternatively, by using pure substitution, what you will see is let 2x plus 3 equals t. Okay, that tells me 2 dx will be equal to dt. Is that okay? Yes. Therefore, I becomes equal to integral e power 2x plus 3, which is t, and dx is equal to dt upon 2. Okay, 1 upon 2 comes out. Integral of e power t will be e power t plus a constant term, and this will be equal to 1 by 2 times e power t. T is 2x plus 3 plus constant of integration. Yes. Do you see that we get the same thing? Yes, we should get the same thing, right? And that's all in this particular question. In the 17th question, we have x upon e power x square. Okay, so e power x square is creating a problem, but then we can handle this very easily. X upon e power x square. Now the derivative of x square is present in the numerator. Don't you see that? Yes. So let x square is equal to t. That tells me 2x dx will be equal to dt. Therefore, I becomes equal to what? X dx is 1 upon 2 dt. Okay, 1 upon 2 can come outside the integral. And in the denominator, you will have e power t. This is actually 1 by 2 integral of e power minus t dt. Okay, that's interesting. E power minus t has to be handled now. Once again, this is a linear function of x, and this is equal to 1 by 2 e power minus t upon minus 1. You have to divide by the coefficient of that t, right? Linear polynomial of this, and this is what you get. So what will this be equal to? Let's see. This is minus 1 by 2 e power minus x square plus constant, or you can write it as minus 1 upon 2 e power x square plus constant as the final answer for this 17th question over here. 18th question says we have e power tan inverse x over 1 plus x square, and you see the derivative of tan inverse x is 1 upon 1 plus x square, which is present over there. So we'll take, let tan inverse x is equal to t, which tells me okay 1 upon 1 plus x square times dx is equal to dt. Once you know this, therefore I can be written as integral of e power t times 1 upon 1 plus x square times dx is dt. This is what you get. And what is the integral of e power t? That's pretty simple. E power t plus constant of integration. This becomes e power tan inverse x plus constant of integration. That's the required answer for this question. Very simple. Yes. Let's discuss this 19th question next. The question says e power 2x minus 1 upon e power 2x plus 1 has to be integrated. How do we deal with this? Okay, the derivative of e power 2x plus 1 is simply e power 2x. It is not e power 2x minus 1, right? So, one of the ideas is we can split and maybe think of some ways to solve it. But another idea that you can follow over here is I equals e power 2x minus 1 upon e power 2x plus 1 dx. What I want to do is this 2x is creating a problem and this minus 1 plus 1 is creating a problem, right? So, observe this carefully. I'll multiply, or you can say that I'll divide the numerator and denominator by e power x. So this becomes e power x minus e power minus x over e power x plus e power minus x, and that is the important step. That is the important step. Once you do this, now you can let e power x, the denominator, e power x plus e power minus x is equal to t. Okay, with the help of this, what you can see is e power x minus e power minus x times dx is equal to dt. This is what you observe, right? Therefore, I is equal to integral of dt upon t, which is log mod t, plus constant, which is equal to log modulus of e power x plus e power minus x plus constant. That is my required answer for this question over here. This is the 19th question for us. In the 20th question, we have e power 2x minus e power minus 2x upon e power 2x plus e power minus 2x. Now, this is a simpler question from as compared to the previous one. Here, you can directly observe, okay, the derivative is present over here multiplied by 2. The derivative is present over here multiplied with 2 once again. So, we can directly substitute denominator. Let e power 2x plus e power minus 2x is equal to t. That tells me, okay, e power 2x times 2 minus e power minus 2x times 2, and dx will be equal to dt. This tells me, okay, e power 2x minus e power minus 2x times dx is equal to dt upon 2. Therefore, I can write the integral. Therefore, I will be equal to integral of, this is there in the numerator, along with dx, it becomes 1 by 2 dt. In the denominator, you have t. This becomes 1 by 2 log modulus of t plus constant of integration, which is equal to what? This is half log of modulus e power 2x plus e power minus 2x plus constant of integration, and that is my required answer for this 20th question, as you can see over here. Next, question number 21 says we have to integrate tan square 2x minus 3. Now, tan square something, tan square x, if that's there, we can convert it into sec square x minus 1, and we can integrate sec square x, we can integrate 1, right? A similar thing is going to be happening over here. So, tan square 2x minus 3, what will that be equal to? So, tan square something can be written as I tan square 2x minus 3. Although this is a linear polynomial of x. So, I can deal with simple idea of either of substitution or a direct result, as we have seen that integral of fx dx, if it is equal to capital Fx, then integral of f of ax plus b will be equal to capital F of ax plus b divided by a, right? That's something which is there. So, I can use that idea. This becomes tan square something becomes sec square 2x minus 3, tan square theta is sec square theta minus 1 with respect to x. This is what you have. Is that okay? Yes. And what is the integral of this sec square? So, sec square 2x minus 3, the integral will be equal to tan of 2x minus 3 divided by the coefficient of x, which is 2. 1 with respect to x, the integral is x plus a constant. This is what you get, and that is my required answer for this question. Alternatively, you could have taken 2x minus 3 as variable t, and you could have solved the question in that way as well. You would have obtained a similar result, or exactly same result maybe. In that case, let me give you a hint. You would have obtained tan of 2x minus 3 upon 2 minus of 2x minus 3 upon 2 plus some constant of integration. If you had followed that, after resubstituting, this is what you'll get. And this term is same. What about this term? Do you observe that this is minus x plus 3 by 2 plus c1. c1 is a constant, 3 by 2 is a constant. They can be clubbed together to give you another constant c, and yes, matching answers, right? Interchangeable. So that's the 21st question for us. In 22nd question, we see sec square 7 minus 4x. Now, how do we handle this? Pretty simple. Sec square, the integral is, this is a linear function, right? So, sec square something, integral will be equal to tan of 7 minus 4x divided by this minus 4 plus constant. That is my required answer. Or you can use substitution 7 minus 4x equal to t. You can do that as well. But this is the final answer. That's the 22nd question. In this question, we have sine inverse x upon root of 1 minus x square. If you observe, both the things are pretty complicated, yes. But the derivative of sine inverse x is this. So we can assume sine inverse x, let sine inverse x equal to t, which gives me 1 upon root 1 minus x square dx is equal to dt. Therefore, I integral becomes equal to t upon this under dx upon under root of x square is actually dt, right? So there is no need of upon. This is dt. So that becomes t square by 2 plus constant, which is sine inverse x whole square half plus constant is my answer. This is what you have. That is the final answer for this 23rd question, as you can see over here. 24th question, we have 2 cos x minus 3 sin x. In the denominator, we have 6 cos x plus 4 sin x. How do we deal with this? So the derivative should be present in the numerator. Yes, the denominator looks pretty complicated, but if you observe, you can take a factor of 2 common from here. Yes, and in the numerator, you will have 2 cos x minus 3 sin x. In the denominator, what you will have is 3 cos x, let's write 3 cos x over here, plus 2 sin x, right? Just rearranged a bit. Why do we do that? So that you can observe the derivative of this is exactly there in the numerator, right? Yes. So 2 sin x plus 3 cos x can be written as t. This makes this 2 cos x minus 3 sin x dx is equal to dt. Therefore, this becomes equal to what? Half of integral dt upon t, which is half log mod t plus constant. What is that? Half log of modulus t. T is this 2 sin x plus 3 cos x plus constant, and that is my required answer for this 24th question, right? 25th question says we have to integrate 1 upon cos square x divided by 1 minus tan x and a square over there. How do we handle this? Okay, this 1 upon cos square x is nothing but sec square x, is it not? Yes. And the derivative of tan x is present in dx, yes. So I is actually sec square x upon 1 minus tan x square dx. This is what you have, right? So I can substitute tan x, or for that matter 1 minus tan x as t. 1 minus tan x equal to t implies minus of sec square x dx is equal to dt, or therefore you can say that I will be equal to sec square x dx, which is minus dt upon this is t square, right or not? Yes. The integral of t power minus 2 will be minus 1 upon t, yes or no? Yes. So this becomes 1 upon t plus constant, and this is 1 upon t means 1 minus tan x plus constant. That is my required answer for this question over here. 26th question says you have to integrate cos of root x upon root x. Okay. that root x in the denominator is derivative of this root x, right or not? Yes. So let root x equals t, because cos of root x is difficult, but cos t is simple, right? This tells me 1 upon 2 square root of x dx is equal to dt. Therefore, I becomes equal to integral of dx upon root x. Dx upon root x can be written as dt times 2. Okay, and you have cos of root x, which is cos t. In the denominator, you will get 1, right? So this is what you'll get: integration of 2 times integral of cos t. Cos t integral will be equal to sin t plus constant, which is 2 sin root x plus constant, is my answer for this question, as you can see over here. 27th question says root of sin 2x times cos 2x. Okay, how do we handle this one? The derivative of sin 2x is cos 2x, right? So we'll take sin 2x is equal to t. The derivative is cos 2x times 2 dx. Okay, that becomes dt upon 2 when the 2 comes over here. This is equal to this. Therefore, I integral of root sin 2x becomes t, and cos 2x dx becomes dt upon 2. 1 by 2 is okay. The integral of t power 1 by 2 is t power 3 by 2 upon 3 by 2 plus constant. Because 1 by 3, t power 3 by 2, t is sin 2x. So sin 2x power 3 by 2 plus constant is what I see over here. That's our final answer for this question. 28th question says cos x upon root of 1 plus sin x. So once again, 1 plus sin x, the derivative is cos x. So 1 plus sin x can be taken as t. Therefore, cos x dx will be equal to dt. This is important. Therefore, I is equal to dt upon root of t. And what's the integral of t power minus 1 by 2? That is t power minus 1 by 2 plus 1, that is t power 1 by 2 upon 1 by 2, that is 2 t power 1 by 2 plus constant, or you can say 2 root t plus constant. T is equal to 1 plus sin x. This is 2 1 under root of 1 plus sin x plus constant. That's my answer for this question over here. 29th question says cot x times log of sin x. Okay, pretty interesting. Now log of sin x in itself is simple, but log sin x is complicated. So I is equal to cot x times log sin x, and do you observe that I can take log sin x as t, and what will that give me? If I take log of sin x as t, that tells me, okay, 1 upon sin x, derivative of sin x, since we want to apply the chain rule, derivative of sin x is cos x times dx is equal to dt. Okay, that tells me that cot x dx is equal to dt. This tells me cot x dx is equal to dt, and I can use that cot x dx with this integral. Therefore, I becomes equal to what? Integral of cot x dx. Cot x dx is dt, right? So this is dt, and log sin x is t. This is t dt. That becomes t square by 2 plus constant, which can be written as 1 by 2 t square. What is t? Log of sin x square plus constant is my answer for this question over here. 30th question has sin x upon 1 plus cos x. Pretty simple. 1 plus cos x can be taken as t, right? So integral of sin x upon 1 plus cos x dx. We can take 1 plus cos x as t, and that tells me derivative of cos x is minus sin x. Minus sin x dx will be equal to dt, and this further tells me, okay, sin x dx is minus dt, and 1 plus cos x is t. So this is what you have, right? And derivative integral of 1 by t, this is minus 1, log of mod t is what you'll get plus constant. This is log of modulus t power minus 1 is what you'll get, and that can be done as 1 upon t, yes. So 1 upon t will be 1 upon 1 plus cos x with the modulus plus constant. That's my answer for this question over here. That's all, yes. The 31st question says sin x upon 1 plus cos x square. Okay, so a similar question to the previous one. Once again, you can begin with 1 plus cos x is equal to t, that tells me, okay, minus sin x dx is equal to dt. And from here I can say therefore I is equal to minus dt upon t square. Do you observe that 1 plus cos x is t, therefore denominator becomes t square. In the numerator you will have sin x dx, which becomes minus dt. Okay. Integral of this expression is 1 by t plus c. This is what you will have. T power minus 2, the integral will be t power minus 1 upon minus 1. That minus will get cancelled with that minus 1, and this is what will give, what will remain over here. This is 1 upon 1 plus cos x plus constant, and yes, that's the required answer for this question over here. Question number 32 says integrate 1 upon 1 plus cot x. This is a pretty interesting one, and observe carefully how this kind of question will be handled, right? So I is equal to integral of 1 upon 1 plus cot x. 1 plus cot x, if you take a look at this carefully, in the denominator it is creating a lot of problems, but even if you try to bring it in the numerator, it will not be possible, right? The derivative, there's nothing in the numerator, right? So let's create something in the numerator. And one of the ideas could be to multiply by 1 minus cot x, 1 plus cot x, 1, no, it will not help. But then cot x can be converted into cos and sin, and what I'll get in the denominator is cot x is cos x upon sin x plus 1. So this becomes cos x plus sin x, and this becomes sin x, right? Dx. That's what you get. Multiplying and divide by sin x. That's what you get. Okay. Multiplying numerator and denominator by sin x is what you will get. Now, after reaching this stage, I remember something from the past few questions that you remember that question which had 6 sin x plus 4 cos x and 2 sin x plus 2 cos x plus 3 sin x in the numerator. So, sin cos can be converted in terms of sin cos, right? The derivative can be written in terms of sin cos. That's something which is useful, right? So, derivative of cos x plus sin x will be equal to this cos x, the derivative will be minus sin x, the sin x, the derivative will be cos x, right? That's what you'll have. So, you'll have to create some cos x over there. Okay. And how do we do that? So, let's do one thing. Instead of a single sin x, let's create 2 sin x. Okay. Half is okay. What I have done is I have created 2 sin x so that I can write it as sin x plus cos x once and plus sin x minus cos x again for creating that extra sin x. Mind you, this converts to its derivative, but this can also be converted, right? I can write cos x plus sin x also in the numerator because that will simplify, right, and that's the beauty of this step. This is very, very important. This particular step, tuck and tuck. These two steps are very, very important, and if you observe these carefully, 1 by 2 integral, this becomes sin x plus cos x, cos sin x plus cos x, this is 1 plus this becomes, okay, the derivative of cos x is minus sin x. So, we can take out a minus common from here. And this becomes this, right? In the denominator, you will have sin x plus cos x, okay. In the numerator, you can take out a minus common, this becomes cos x minus sin x. Now, it is in the exact form in which you want it to be. The derivative of sin x is cos x is minus sin x, the derivative of this denominator is present in this numerator, right? So, for this second term, this first term, the integral is very simple. For the second term, we can take sin x plus cos x as t. And this becomes, this times dx becomes dt. dt upon t, integral is log of mod t. I can write that directly now, yes. We have solved so many questions. So, therefore, I becomes equal to half is okay. In the bracket, you have x minus, once again, this is dt upon t, right? So, that becomes log of modulus t, which is sin x plus cos x modulus plus constant term, right? So, this is x by 2 minus 1 by 2 log modulus sin x plus cos x plus constant. That is my required answer for this question over here. Pretty interesting, right? This is a very important step. The 33rd question says you have to integrate 1 upon 1 minus tan x. Okay, and just in the previous question we have seen an idea, yes. And we can use that idea over here as well to give us something very simple. Integral of, this is tan x can be done as sin upon cos. So, this, in the denominator it becomes cos x minus sin x, and this will go over here, this becomes cos x dx, right. the first thing that we'll do is we'll try to create cos x minus sin x and cos x plus sin x in the numerator, right? So let's do that. Multiply with the 2, divide by the 2. Half times integral of this becomes cos x minus sin x first, and the next term will be cos x plus sin x. If you observe carefully, this cos x plus cos x minus sin x plus sin x gets cancelled, right? So cos x minus sin x is what I'll get. This is equal to this. And now I can separate these two terms. 1 by 2 is okay. I can separate these two terms like this. 1 by 2 times integral of this becomes, okay, 1 plus this cos x plus sin x. Okay. So cos x plus sin x is what I get over here. In the denominator I have cos x minus sin x dx. Now, if you observe carefully, the derivative of cos x is minus sin x, the derivative of minus sin x is minus cos x. So what we'll get is minus of this whole thing as the derivative, right? So we'll have to separate this out. Let's write a few more steps. 1 by 2 times integral of dx plus 1 by 2 times integral of the second term, which is cos x plus sin x upon cos x minus sin x dx, right? This is what you have. This integral is pretty simple. This is x by 2, and after integrating this we'll write the constant of integration. But what about this one? So let's skip this step and let's use the substitution first. Cos x minus sin x can be taken as t, and what does that give me? Minus sin x minus cos x times dx is equal to dt, right? So this numerator times dx becomes minus dt. Therefore I is equal to x by 2 plus 1 by 2 over here, integral of minus dt upon t. This is what you get, right? So this x by 2 is pretty simple. This is minus 1 by 2. The integral of 1 by t is log mod t plus constant, or it becomes x by 2 minus 1 by 2 log modulus t. T is cos x minus sin x plus constant of integration, and that is my answer for this question over here. This is the third question for us. The 34th question says we have to integrate root tan x upon sin x times cos x. How do we handle this? Root tan x is creating a problem. So one of the ideas is we can substitute tan x equals to t. Yes, and that is the idea that will work over here. But first we'll have to create the derivative of that tan x. Okay, can I create a sec square x over here? Multiply by sec square x. That's what you mean to say? Yes. This is sin x into cos x dx. What I want to do is multiply with the sec square x and divide with the sec square x. Yes. So root tan x is okay. You'll have a sec square x over here. What about this? Sec square x into cos x, there will be one sec x remaining, which is 1 upon cos x. Sin upon cos will become tan x over here. Okay, so everything converts in terms of tan, and this is derivative of tan. Now we can use the substitution. Tan x is equal to t. That tells me, okay, sec square x dx will be equal to dt. This is what you get, right? Therefore, I becomes equal to what? I is equal to integral of root t upon t dt, or you can write it as integral of, this is t power minus 1 by 2 dt. The integral of t power minus 1 by 2 will be t power 1 by 2 divided by 1 by 2, which comes over here, plus constant, 2 root t plus c, which is 2 root of tan x plus constant. That is my required answer for this question, as you can see with all these steps, right? The important step, first step is the important one, where you think that you have to substitute tan x equal to t, right? That substitution is important. Once you substitute that properly, things will become very simple. The 35th question says 1 plus log x square divided by x. Now if you observe, the derivative of log x is present over here, yes, and that's what we are interested in. So we can take 1 plus log x as t, and that gives me 1 by x dx is equal to dt. Therefore, the integral will be equal to t square times dx upon x becomes dt. This is what you get, which is t power 3 upon 3 plus constant. This is what you get. So this is 1 by 3 times t power 3, which is 1 plus log x power 3 plus constant. That is my required answer for this particular question, 35th. In the 36th question, in this question we have x plus 1 upon x and x plus log x whole square. This whole square term, this is creating problem. And if you observe carefully, I is equal to what? Let's look at all the other terms. X plus 1 upon x is actually 1 plus 1 upon x. Right? X plus 1 upon x. Then you have x plus log x square dx. This is what you have. And now you may be able to guess very easily that if I take x plus log x equals t, its derivative, which is 1 plus 1 upon x along with dx, will become dt. Yes, 1 plus 1 upon x times dx is dt, right? If you observe that, then I becomes equal to integral of t square dt. And this is 1 by 3 t power 3 plus c. That's it, right? 1 by 3 is okay. T is x plus log x power 3 plus constant. This is what you get. That is my required answer for this question over here. The 37th question says x power 3 sine of tan inverse of x power 4. Oh, so many complicated things. Had it been only sine theta, we could have integrated that. But if you observe that tan inverse x power 4, which is creating the maximum problem, can be taken as t. And rest all the expressions written along with that give you the idea of substituting it as this. The derivative was 1 plus 1 upon 1 plus x power 4 square. The derivative of x power 4 is 4x power 3 dx, which is equal to dt. Now from here I observe that x power 3 upon 1 plus x power 8 along with dx. Please observe, this is 1 plus x power 8, this is x power 3, 4 is extra, so that 4 can be brought over here. This times dx is dt upon 4. So x power 3 upon 1 plus x power 8 times dx will be dt upon 4. Therefore, I is equal to sine of t dt upon 4. This is what you have. Simple. Integral of sine t, 1 upon 4 is okay. Integral of sine t will be minus of cos t plus a constant. This is minus 1 by 4 is okay. Cos of t, t is that tan inverse x power 4. This is what you get, tan inverse x power 4 plus constant, and that is my required answer for this question over here. Looks pretty complicated, but yes, it is not very complicated, it's simple. Once you can guess the substitution, it becomes very simple. The 38th question says we have to integrate 10x power 9 plus 10 power x log 10 upon x power 10 plus 10 power x. Okay. And seeing the options also you can guess something, but still if you observe carefully, x power 10 plus 10 power x, both the things are pretty complicated in the denominator, right? And if I take it as t, do you observe that the derivative of x power 10 is 10 x power 9? Oh, it is present over there, yes. And what's the derivative of 10 power x? 10 power x, the derivative is 10 power x log 10. Obviously, the base will be natural base e. This dx is equal to dt. And what is this? This is there in the numerator, yes or no? Yes. So therefore, I becomes equal to integral of dt upon t, which is equal to log modulus of t plus constant. This is equal to log modulus of t plus constant, and this becomes log modulus of t. T is x power 10 plus 10 power x plus constant. That is my answer. And which of these options is the correct? The correct option is this D over here. Is that okay? Yes, that's pretty simple, as you can see. The 39th question says dx upon sine square x cos square x. How do we integrate this? Now, integration of this, it is better if you try to differentiate the options. That's one idea, since this is an objective question. But then sine square plus sine square into cos square can be handled in this manner. What is this actually? Sine square plus cos square is 1, right? Okay, if sine square plus cos square is 1, can I replace 1 by this? Yes. And what do we have in the denominator? I have sine square x times cos square x in the denominator. Now this is borrowed from the ideas of trigonometry, right? Borrowed from the ideas of trigonometry. In trigonometry, we have solved such kinds of question where, right, sine square x into cos square x and the denominator is converted to something else, x square x plus cos square x, right? How do we convert that? With the help of this. So this becomes integral of this upon this whole term, which is 1 upon cos square x, plus cos upon this is 1 upon sine square x dx. Okay, and what is 1 upon cos square x equal to? This is sec square x, and this here is cosec square x. Oh, and I know the integrals of these two. Yes, you know the integrals of these two. Integral of sec square x is tan x. Integral of cosec square x is minus cot x plus constant. That is my required answer for this. Tan x minus cot x plus c. And the correct answer, as you can see over here, is B. Tan x minus cot x plus c. That's the correct answer for this question, as you can see over here. And with this, we come to the conclusion of this exercise 7.2 from the chapter integrals. Till the next session, all the best.